Hmm. All right, guys, your essential question is, how do we recognize, analyze, and graph ellipses? So we're going to be looking at ellipses today. For ellipses, the vocabulary words are foci and vertices and major and minor axis. And then we have co-vertices and center. So that's what we're going to be looking at for today. Now, ellipses are not so perfect circles, are ovals. And so what we're going to be looking at are oval shapes. And so the formal definition is, an ellipse is the set of all points in the plane such that the sum of the distances from the foci is the same. Or you can say foci. Foci is the same. So for example, this is a picture of an ellipse, and the two foci are right here in blue. And the ellipse is the set of all points in the plane such that the sum of the distance from the foci is the same. So in other words, from this point P to that focus, and this distance from that focus, if you add those two together, whatever that value is, that is the same value at every single point on the ellipse. So vocabulary-wise, the line that goes through the foci intersects the ellipse at two vertices. The major axis joins the vertices. Its midpoint is the ellipse's center. The line perpendicular to the major axis at the center intersects the ellipse at the two co-vertices, which are joined by the minor axis. Alright, the major thing you need to remember is that whatever the major axis is, that's where your vertices and your foci are. So just keep that in mind. Your major axis could be horizontal, or it could be vertical. But whatever your major axis is, the foci and the vertices are on that major axis. The co-vertices are on the minor axis. So the standard form equation for an ellipse is written right here, depending on if it's horizontal or if it's vertical. Now if you notice, I've got x squared over a squared plus y squared over b squared is equal to 1. The major thing about an ellipse is that an ellipse, the equation in standard form, is always set equal to 1. The foci, the way that you find that is you have to know what the distance of C is from the center. So the formula for that almost looks like the Pythagorean theorem. It's C squared is equal to A squared minus B squared. So the two major things you need to remember is that 1, an ellipse is always equal to 1, and 2, the foci, the formula is C squared equals A squared minus B squared. So let's say that you were asked to graph this ellipse. And I know that this is an ellipse and not a circle because, first of all, it's equal to 1, but also because I noticed that the coefficients in front of each of these terms is not the same. This is 1 over 16, this is 1 over 25. So the way I would graph this is first identify where my center is. My center is at the point 0, 0, since there's nothing with that x and that y. So I'm just going to put a point at 0, 0. Now, my x-axis, you see the 16, so the square root of 16 is 4, which means that from my center, I'm going to go left and right 4. And so that would be on the x-axis. The y-axis, notice there's a 25, so the square root of 25 is 5, so I would go up and down 5. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. And so those 4 points, that would form my ellipse. And so if I were to label this, I notice that my major axis, which is the longer one, in this case is my y-axis. And so this is my major axis, which means my vertices are on my major axis, which will be at 0, 5 and 0, negative 5. My minor axis would be on the one that's shorter, and so it would be at these points 4, 0 and negative 4, 0. And so those would be my co-vertices. So negative 4, 0, and that would be that point right there. So in red, the co-vertices, in blue, the vertices. Alright, once you found out where the major axis is, you can find out where the foci are. So I'm just going to change colors right quick. So remember, the formula to find the foci is c squared is equal to a squared minus b squared, where a squared and b squared are your numbers in the denominator. So it would be 25 minus 9, so that would be 16, and then the square root of that would be 4. So that means from the center on the major axis, I would go up 4, and I would go down 4, and that's where my foci would be. And so I would label those 2 points 0, 4, and 0, negative 4, and that would be my 2 foci. Alright, if you look at another one, if we were to graph this one, again, the center of my ellipse is at 0, 0, and so then I'm going to plot that point at 0, 0. On the x-axis, the square root of 25 is 5, so I'm going to go left and right 5. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. My y-axis, so the square root of 9 is 3, which means I'm going to go up and down 3. So 1, 2, 3, 1, 2, 3. And so there would be my ellipse that combines all 4 of those points. So my major axis, I notice, my major axis is my x-axis, and then so that means that these would be my vertices at 5, 0, and negative 5, 0. Sorry, that's not right, negative 5, 0. And then my co-vertices in red would be on my minor axis, which would be at 0, negative 3, and 0, 3. And so those would be all of that information right there. Alright, once you know where your major axis is, then we can figure out where my foci are. So for my foci, I'm going to use the formula c squared is equal to a squared minus b squared. And so I would use 25 minus 9, that would be 16, and then the square root of that would be 4. So on my major axis, I would go left and right 4. So I would go left 4 and right 4, and that's where my 2 foci would be, which would act to the points negative 4, 0, and at 4, 0. And that would be my answer for that problem. Alright, now, remember, the main thing with an ellipse is that an ellipse has to be set equal to 1. So if your equation's not set equal to 1, the first thing you would want to do is to get it equal to 1. So since this is equal to 36, I'm going to divide everything by 36, and so that'll reduce to x squared over 4 plus y squared over 36 is equal to 1. And then I can graph this. My center would still be at 0, 0, so I would just plot a point at 0, 0. The x-axis, the square root of 4 is 2, so I would go left and right 2. My y-axis, the square root of 36 is 6, so I would go up and down 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And so those would be my 4 points, and there would be my ellipse. Once I know my ellipse, then I can say, well, my major axis for this problem is my y-axis, and so that means that's where my foci are going to be. So to find my foci, do your formula c squared equals a squared minus b squared. So in this problem, it would be 36 minus 4, which would be 32, and then just take the square root of that. So my value for c would be square root of 32 on the y-axis, which would mean it would be somewhere that's up here on the y-axis. So that would be the point 0, positive square root of 32, and 0, negative square root of 32. And that's where my 2 foci would be. Now, sometimes it might be necessary to write the equation of your ellipse if you're given some information. So for example, let's say I have an ellipse that's centered at 0, 0. Well, I already know that this is going to be x squared plus y squared is equal to 1, and I'm going to have 2 denominators. Well, the other part in red and blue gives us our information. It says my vertex is at 5, 0. Notice that it's the x value for my vertex. So that means that the x value, 5, square that, 5 squared, and then over here the covertex is at the point 0, 4. Notice the 4 that's in the y value, and so then that would be 4 squared underneath the y. So my equation would be x squared over 25 plus y squared over 16 is equal to 1. And that will be the equation of my ellipse. We practice one more. This one is also centered at 0, 0, and so I would go ahead and put x squared plus y squared is equal to 1. Notice that my vertex is at the point 0, 3. Notice the 3 is in the y value, so I'd have 3 squared. The covertex is at negative 1, 0. Notice that that's the x value, so that would be negative 1 squared. So that would be x squared over 1 plus y squared over 9 is equal to 1. And that's how you do problems just like that.